We will talk about NoSQL and NewSQL databases, and we will also offer a concise comparison of some certain characteristics between SQL, NoSQL, and NewSQL. We have said before, when we were talking about big data and complex data types, that unfortunately, relational databases have their limitations there and are not super efficient in managing big amounts of data that are unstructured or semi-structured. And that, of course, posed a challenge with the increasing production and need for collection and storage and processing of such data. NoSQL is a type of database that came to address some of the challenges posed by big data and by the growing scalability needs in database systems. The NoSQL databases can handle various types of data. They are scalable, that is, they adapt well to increasing needs in relations, entries, and other needs, and they can also be very efficient in distributing the data across multiple sites or servers. Some popular NoSQL databases are the MongoDB, the Cassandra database, and the Neo4j database, which we have already mentioned in earlier chapters. Why would you want to use a NoSQL database, or rather, what type of advantages come they with? One important aspect is the use of dynamic schemas. That means that a NoSQL type of database allows that inside one relation, different records can have different attributes. For example, in a relation, students, for example, you might have some records for which you have their ID, their number, their age, their home address. This is the attributes for these records. And you might have some other records for which the attributes that you have is their ID, their name, and their email. But that does not mean that all other fields are filled with non-values. No, it means that this is all the attributes you have for these records, dynamic schemas. And we already said how scalable NoSQL databases are. This is a good choice if you expect your system or your applications to grow, or you might need new data types supported in your system in some future, etc. It is also good for big data applications, which are pretty much most businesses and organizations focus these days, and they, generally speaking, have lower cost. And they can be used and are used for various types of applications, for example, in social media applications, in gaming, in the Internet of Things related applications, but also for tracking goods and records in supply chains. There are basically 4 types of NoSQL databases, namely graph databases, document databases, key-value databases, and column-oriented databases. As we have discussed graph databases before, let me just remind you some types of applications where this type of database is suitable. Some examples are social media applications, financial transactions, and other financial and accounting applications, but also network-based mapping and analysis, and more. Document databases store data as documents in a JSON-like way, if you're familiar with the JSON files. And it is quite useful for storing data in various types of formats. One great thing about this type of database is that they have no limitation in terms of the format and structure of the data storage, and we say that they are schemaless. They are often found in content management systems and e-commerce applications. One popular database suite for this is the MongoDB, but of course, it has its limitations in the sense that this is not a general-purpose database and it can only do things related to document-like data. In key-value databases, data is stored in a type of structure that is like a table with 2 columns, one column being the keys and the other the values. So its data item has a key-value pair information where the data is in the value and the key is some identifier for that particular data item. The values, that is, the data, can be of any data type and different ones in one particular structure. This type of database is perhaps the simplest available, and it is suitable if your application is quite simple and only needs to answer queries of the type, here is some identifier of an object, show me all the information you have on that particular object. It cannot select parts of information for a particular object. Amazon DynamoDB is of this type. And lastly, we have the column-oriented NoSQL databases. Now, in relational databases, we have data stored in relation in rows. Here we have them in sort of like tables, but in columns. This is how they are represented. And the columns are treated separately. This type of database is quite suitable for Internet of Things applications and large-scale distributed systems. Some examples for this is the Apache Cassandra and the H-based platforms. However, as both SQL and NoSQL have limitations, a natural advancement is to create some type of a database that combines the two. This is the new SQL, which is often referred to as a bridge between SQL and NoSQL, as it tries to combine the best of the two. Here, databases are engineered as relational databases, but they have a distributed architecture and some other neat features. For example, they support horizontal scalability, that is, the data can be partitioned and distributed across various nodes or sites. It is also compliant to the ACID requirements, that is, it guarantees atomicity, consistency, isolation, and durability as relational databases do. They offer high performance through various nice features, for example, through in-memory processing or indexing, etc. And through data replication, they guarantee high availability of data, but also fault tolerance. And an added bonus is that they are compatible with SQL, which is still pretty useful for simple queries. NewSQL is, generally speaking, a really nice solution for most applications, but if you require strict ACID compliance, you better go with SQL databases. Also, going with NewSQL is perhaps a bit of an overkill if your database doesn't expect to grow and it is a simple system with well-established data models. Here, I would like to summarize some of the main features in comparison across SQL, NoSQL, and NewSQL types of databases. Both SQL and NewSQL are relational to a high degree, but NoSQL is not, as it is a NoSQL. As such, NoSQL is also not compliant with ACID, A-C-I-D. In terms of online transaction processing, which is often the goal, SQL is rather inefficient. NewSQL fully supports it with high efficiency, whereas NoSQL can support it, but not in an ideal way. In terms of scalability, only NewSQL supports both vertical and horizontal scaling. Simple queries are handled fine by SQL. NoSQL is better than SQL in handling complex queries, but NewSQL is efficient in both simple and complex queries. And finally, both NoSQL and NewSQL support distribution, something that SQL does not. In summary, big data, speed, scalability, and some other features have caused the creation of other types of databases other than relational ones. One such type, the NoSQL database, can support several types of data. They are flexible, scalable, and support distribution, but they do not support traditional SQL. NewSQL is a type of database that combines the strongest features from SQL and from NoSQL, and unless your application is super simple and static in terms of expected growth, then this is a very good option.